Hi guys, this is another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today we're going over 7.3, simplifying algebraic expressions. Specifically, how to take an expression and combine the things that can be combined and leave it when you can't do anything else with it. We have 4 vocabulary terms. Our first one is simplify. This is what we're going to be doing. So simplify means to write an expression by combining like terms. Combining like terms. That means taking terms that are similar to each other and combining them through addition or subtraction. Example of this would be, let's say we have the expression x plus 3x plus 4. You would go through and look at what is like each other and what is not, what can be combined and what can't be, and you would, through work, get a simplified expression like 5x plus 4. So 5x plus 4 would be the simplified version of x plus 3x plus 4. I took what can be combined, specifically in this example, the x, the positive x, and the 3x, and got 5x. Well, you can't add a regular number to letters, so it's just hanging out there on the side. So this is as far as I can get. You can't combine those. Those are not like each other. Which brings us to our second term, like terms. Like terms refers to terms with the same variables and with the same exponents. We're going to focus on same variables. We won't get into dealing with same exponents until 7th grade and even 8th grade standards. All right, so for now, quick example of showing what like terms is referring to. In the example 2x plus 4 plus x plus 6, you'll notice which ones have the same variables? Well, the 2x and the positive x. They both have x's, so they're like, part of the x club. So that means 2x and positive x, they are like terms. So 2x and positive x. It is important to include the signs in front of your numbers or variables because later on that's going to tell you if you should add or subtract them. So anyways, what does this mean? This means you can do stuff with them. You can take 2x and positive x and you could add them, you could subtract them, you can do stuff with them. What about the positive 4 and positive 6? Well, they don't really seem to have a variable. They technically do. If you were to write this, it would be like saying 4 with a variable next to it, but it would have an exponent of something other than like 2 or 3. It's kind of hidden. You're not going to really get into that until 7th or 8th grade standards. So for our purposes, we're going to simply say these are like terms because they appear to not have a variable. They're both similar to each other and that they're both plain old numbers. So that's as much as we're going to get into on that. So positive 4 and positive 6 are like terms because they both don't have a variable, seemingly. And again, in 7th and 8th grade, you'll find out that they do, but it's more of a conversation than we want to have right here. So 2x and positive x are like each other. That means you can do stuff with them. 4 and 6 are like each other. That means you can do stuff with them. But 4 and 6 are not like 2x and x. Why? They don't have the same variables. Next one, coefficient. Coefficient is simply the number in front of the variable. It's important to note that all variables have a coefficient, whether it looks like it or not. So this variable right here, x, it doesn't look like it has a number in front of it, but it does. Kind of like I was talking about that these have variables behind them, it just doesn't look like it. Some things are just hidden and we don't write them because it's unnecessary. So what number would be in front of this x? Well, just a 1. But it's not important to write a 1. So we simply just leave it as x. So don't forget those hidden things. All right, so quick example of a coefficient. In the example, 8x plus 3. What's the number in front of the variable? Well, our variable's x. What's in front of it? 8. So 8 is the coefficient. What's the purpose of a coefficient? It basically tells you how many of them there are. And those are the numbers that you're going to use to add or subtract and so on. So if I go back up here, x, x, and 3x, how did I get that 5x? Well, I added the coefficient. There's technically a 1 in front of that x. I just don't need to write it. There's a 1 in front of that x, and then there's a 3 in front of that x. So I took the 1 and added 3. And that's how I got my 5x. So that's what you're going to be using your coefficients for. All right, our last vocabulary term, equivalent expressions. These are expressions that are equal for all values of the variable. Example, let's say I have 5x plus 7x, and I have 12x. Both of these are equal because if I take any number for x, whether it's -1, 10, 5, doesn't matter, these are going to come out to the same answer. So, quick demonstration. If I chose x to be 2, well, I would do 5 times 2 and get 10, plus 7 times 2, which is 14, and I'm going to get 24. Again, x we chose to be 2. So 12 times 2 would be 24. And it doesn't matter what I choose x to be, that's going to come out to the same answer. So that means 5x plus 7x and 12x are equivalent. Because it doesn't matter what I choose that letter to be, both expressions are going to come out to the same value if I were to evaluate them. All right, before we get into our practice problems, I'm going to do a quick demonstration of some addition. So let's say I have 2 groups of 4. If I wanted the total, I could do 4 plus 4. How else could I do 4 plus 4? Well, I have 2 of them, right? And repeated addition is the same as multiplication. So instead of doing 4 plus 4, I could do 2 times 4 to get my answer, right? Because I have 2 of them. Another quick example or demonstration of this. Let's say I have 2 5s and I wanted the total. Well, I could do 5 plus 5. Or, since it's repeated addition, I could multiply. So since I have 2 5s, I would do 2 times 5. One more. Let's say I have 3 7s. and I wanted the total. Well, I could do 7 plus 7 plus 7, or I could use multiplication for that repeated addition and say, well, I have 3 sevens. In other words, 3 times 7. So think of multiplication as how many of something do you see? How many of them are there? So again, multiplication is the same as repeated addition. Awkward silence. No, not really. So multiplication, same as repeated addition. This is going to help you when you're combining like terms. First example, a straw, y inches long, is joined to another straw of the same length, and I want the total length. So let's start out with a picture. I have a straw. It's y inches long. Next, I'm going to join it to another straw the same length. So here's another straw. Oh, it's y inches long because it's the same length. Now, how do I find the total? Total means add. So what do I have? I have y plus another y. Now, just like up here, when I have repeated addition, you can use multiplication to show that. So what is y plus y? Well, that's the same as having 2 of them, and of means multiply. So that's the same as having 2 times y. What is 2 times y? It is simply 2y. So what would my total length be? The total length is 2y. Our label is inches. And that's our answer. That's the total length of the straw. FYI, if I wanted to find the coefficient, my coefficient would be 2, because that's the number in front of the variable. All right, one more note before we go on. In our expression y plus y, when we were actually solving that, what were those coefficients? Because we said all variables have a coefficient. Well, remember those invisible things. When you don't see a number in front of the variable, it's understood to be 1. So y is the same thing as having 1y. We just don't write 1y. Why? Because why write 1y if I only see one of them? You know, it's like, what's the point? Plus, again, y, what's the coefficient? 1. So what were we really doing when we did 1y plus 1y? We were simply just adding the coefficients together. 1 plus 1, you get 2. So 1y plus 1 more y, you get 2y. Again, just another reason of why y plus y is 2y, or 2 times y. All right, let's move on. Number 2, each side of the triangle below has a length of p centimeters. That means we don't know how long it is, but we know that's equilateral because they're all the same. We are going to find the perimeter. And then we're going to state the coefficient of the variable. Not the coefficient of these variables, the coefficient of the variable in our answer. So first, how do you find the perimeter of something? You find the perimeter of something by adding all the sides. So let's do that. This side's p plus the other side's p plus the other side's p. Now we're going to combine those. We're going to work left to right because it's all addition. So think, I have p plus p. That's the same thing as having 2 of them, right? So p plus p would be 2 times p, or 2p. Bring down our plus p. These are like terms. They're like each other. They're both part of the p club, so you can combine them and do things with them. So I have 2 groups of p plus 1 more group of p. You're essentially going to get 3 groups of them, or 3p. Again, what am I doing? I'm simply adding the coefficients in front of the number. in front of the variable. So 2 and that invisible 1. All right, so I get 3p as my total. So first answer, what's the perimeter? We're going to say the perimeter is 3p. Our label is centimeters. Second answer, because it said then state the coefficient. We want the coefficient of our answer. Well, the number in front of the variable is 3. So we're going to say the coefficient is 3. So that's both of our answers. All right, our next example. The figure shows 6 rods and their lengths. So z centimeters, z, 2 centimeters, and 5 centimeters. So we don't know these lengths, but we know those two. We're going to find the total length in terms of z. That means you're going to have z in your answer. And then we're going to state the coefficient of the variable in our expression that we find. So first step, how do I find the total length? That means add. So let's list them out. I have 1, 2, 3, 4 z's. So z plus z plus z plus z. Then we're going to add the 2 and then the 5. All right. Which ones are like each other? Well, these 4 have a variable. They're all the same variable, z. So these z's are like each other. So z, positive z, another positive z, and another positive z. Those are like each other, so I'm going to use circles to show that. Is a 2 like a z? No, that one's a number. This is a letter. So I'm going to use a different shape. So positive 2 is different. What about the positive 5? Well, that's another number like the 2. So why did I just code these with shapes? I'm showing you what can be combined and what can't be. So I can combine the 4 circles because they all have the same variable. I can combine the triangles together because they all both don't have a variable, seemingly. But I can't combine the circles and triangles because these have variables, these don't. These are not like these. So let's combine these 4. So z plus 1 more z plus 1 more z plus 1 more z. I'm going to get 4 groups of z. Now combine your triangle terms, positive 2 and positive 5. We get positive 7. Can I combine the 7 and the 4z? No, they're not like terms. They both don't have the same variable. This one has a z, this one doesn't. So what is my answer? 4z plus 7. You can't do anything else. So first answer, the length is 4z plus 7, in parentheses, centimeters. Why did I put parentheses around these? Because I have more than one term with a label. All right, second answer, state the coefficient. The variable z, what's the number in front of it? 4. So the coefficient is 4. So both of my answers. All right, we're going to go through addition and subtraction and just show you some differences and just reinforce combining like terms. All right, number 4, 3x plus x. Just a quick visual of what we are doing. 3x means 3 times x, or 3 groups of x. And we're going to add one more group of x. So essentially, what are we doing? We're taking x plus another group of x plus that last one, and our answer would ultimately be 4x. Now, I'm not going to draw pictures to do all of these. What would your work typically look like? Well, we have the 3x plus one more group of x. Because they're both like terms, I'm not going to waste time circling them or anything like that. Because they're both like each other, I don't need to do that. So if I have 3x's plus one more x, we are simply going to get 4 groups of x, or 4x. And that is it. This is just a picture of what's going on right there. Now, again, I've said this a couple times, but all single variables, like this x right here, have a coefficient of 1. So what does that mean? When we're taking the expression 3x plus x, what we are really doing is taking 3x plus 1x. So again, all single variables have a coefficient of 1. We just don't write all of those invisible things. It's kind of like if I said, write $4. Well, I'd write $4. Do I need to write the decimal? No, I know it's there. Do I need to write these zeros? No, I know they're there. So again, there are tons of invisible things. Also, I know that all whole numbers are over 1. Do I need to write those? No. So the ones in front of single variables is just one of those things that we just don't have to write. They're invisible. We know they're there. All right, moving on. Number 5, simplify 4z plus 2z. So 4z, 4 groups of z, plus 2 more groups of z. Are they like terms? Yes, they're both part of the z club. They both have a variable. It's the same variable. That's important. So 4z plus 2 more z, we get 6z. That's it. We've combined our like terms. We've simplified it. Next example. Wants to know is 2k plus 6 and k plus k times 6. Are they equivalent? Meaning, are they equal? To do this, you must simplify both. So first one, 2k plus 6. Let's simplify it. Are these like terms? No. The 2 has a variable of k. 6 does not have a variable of k, meaning you cannot combine them. So let's simplify it to 2k plus 6, meaning you can't do anything with it. It's already simplified. So we just copy it down. Next one, parentheses first. So k plus k. Can I do that? Are they like each other? Absolutely. They both have k's. So k plus another k is 2 groups of k. Now we're going to multiply by 6. Even though these are not like terms, one's a number, one's got a letter, they don't have the same variable. Can I do this? I actually can do this. So, little side note. Why can you do this? Well, let's think of it as a picture. 2k times 6. So think, I have 2 k's, and I want to multiply by 6. What does that mean? It means I have 6 of them, right? 6 groups of them. So 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups of 2k's. So again, 2k times 6 means I have 6 groups of 2k's. So what do you see? Well, I see 12k's total. So 2k times 6 of them, I'm going to get 12k. Now let's look at it. Is 2k plus 6 the same thing as 12k? Absolutely not. Not equal. Even if you looked at the beginning, 2k plus 6 and 2k times 6, not the same. But we must simplify both all the way before we can give that final answer of knowing for sure. Next one. Are 3h plus 3h and 6h equivalent? So we're going to go through and simplify both if possible. So 3h plus 3h, are they both like terms? Do they have the same variable? Yes, they both have h's, so I can do stuff with them. So 3h plus 3 more h is 6h. All right, 6h. What is 6h? Well, it's just 6h. You can't do anything with it. It's already simplified, so we're going to write it down, copy it. Is 6h the same thing as 6h? Absolutely. So these are equal. All right, next example. We're going to move into subtraction. Like terms can be subtracted. So first example, 2v minus v. Going to do a quick picture again of what's happening. So I have two groups of v. I want to take away one group. What do I see? Well, I see 1v left. That's what I see. So that's what's happening visually. So I'm going to do this problem the right way. So I have two groups of v. If I take away one group, I simply have v left. Again, all variables have that coefficient of 1, so I could write it like this. So this is just a visual of what's going on. Next one, 5w minus 3w. Are they like terms? Yes, they both have the same variable. So I start out with 5. I'm going to take away 3, and I get 2w left. Again, I haven't been saying this much, but this can only be done when you have like terms. These both have v's, you can do it. These both have w's, you can do this. If one of these terms did not have a w, you can't do it. Kind of like our previous example right here, 2k plus 6. Do not try to add those. That does not say 6k, so you do not get 8k. Why? Because again, they don't have the same variable. You can't do it. That's the hard part about algebra. There are some things you just can't do and you have to accept it. All right, next example, y minus y. Let's just jump in. Y, take away y. Well, if I have 1y and I take away 1y, what do I have left? 0. Or I have 0y. Technically, this is the best answer. I would avoid putting 0y. Why? Well, 0 times anything is simply 0. So technically, this is the most simplified answer, whereas this is not. Now, I'm going to show you visually again why this is 0. If I have 1y and I take away 1y, what do I have? I have none left. I can't get any more direct than that. Again, best answer. Okay answer, but this is technically not simplified. An instructor might not accept that. All right. Now we're going to take our addition and subtraction and put it all together. We're going to use order of operations to simplify our algebraic expressions. So you'll notice we have multiple operations in here. We've got both addition and subtraction, and we have parentheses, and so forth. So it's important to note that you do one step at a time. We're practicing while this is easy, so when you get into higher math with harder examples, it stays easy because you know your steps. And because we're using order of operations and we have multiple operations, it's important to note that you're not always going to work left to right. You don't always work left to right. And you'll see an example of that. All right, first one. We have x plus 6x plus 2x. First, we must know, are they all like terms? Yes, they all have the same variable x. That means I can do stuff with that. So we're going to work one step at a time. Are there any parentheses? No. Exponents? No. Multiplication or division? No. Addition or subtraction? Yes. Addition or subtraction is worked left to right. So x plus 6x, I have 7x. Bring down your plus 2, x. Parentheses, no. Exponents, no. Multiplication or division? No. Addition or subtraction? Yes. Work left to right. 7x plus 2 groups of x, you now have 9 groups of x. 9x is your answer. Next example, 7x minus 5x minus x. Definitely with subtraction, it's important that you work step by step. Don't try to do it all at once. You'll make a mistake. So, no parentheses, no exponents, no multiplication or division. There's addition or subtraction. So I'm going to work it left to right, whatever I see first. 7x, take away 5x, you're going to get 2x. Bring down your minus x. No parentheses, no exponents, no multiplication or division. There's addition or subtraction. I see subtraction. 2x, take away x, you get 1x. Again, you can write the coefficient, but it's better to leave it off if it's 1. Next one. 9x minus 3x plus 2x. Is there parentheses? No. Exponents? No. Multiplication or division? No. Addition or subtraction? Yes. We work addition or subtraction left to right, first come, first serve. So 9x, take away 3x. So you will subtract before you add. 9x, take away 3x is simply 6x. Bring down your plus 2x. All right. No parentheses, no exponents, no multiplication or division. There's addition or subtraction, so do it. 6x plus 2x is 8x. Can't do anything else. That is our answer. All right, next one. 9x minus 3x plus 2x in parentheses. You will not do 9x minus 3x. There are parentheses. You must do them first. So, again, you're not always going to work left to right. See, told you. All right, so 3x plus 2x is 5x. Bring down your minus, bring down your 9x. One more step. What is 9x? Take away 5x, you're going to get 4x. Now, let's mix it up a little bit. Let's include some non-like terms. So, first, we're going to make a note of two things. Remember to only combine like terms. That means if they don't have the same variables, you can't do it. You cannot combine them. Second, you can use shapes, and I did this in one problem. You can use shapes to organize your like terms. Think of them like training wheels. Use them until you don't need them, until you're practiced. All right, so first example. We have r plus 8 plus r plus 8. These are not all like terms because they don't all have the same variable. Only two of them have r's. These two don't have r's. So you cannot combine everything that you see. So we're going to use shapes and show you what you can do. There are two different ways you can deal with problems like this. So first, we're going to pick a shape for the r's. So anything else like an r, well, the positive r is. So I'm going to put both of those in circles. It's important that you include the sign in front of the term. Why? That sign is going to tell you if you need to add or subtract. If you leave off the plus sign, you're not going to know if you should add it or subtract it. Okay, next. What about these 8s? They don't have r's, so they're different. So I'm going to use rectangles. So positive 8, notice I'm including the sign in front of it, and positive 8. So the r's are like each other, and the 8s are like each other, not because they're identical, but because these are both numbers, those are both r's. Okay, so what's one thing you can do? You can rearrange them. So I can put my circles first and my rectangles second, or vice versa. It doesn't matter. So I don't use this method a lot, but it helps beginners sometimes. So basically, I'm going to put that one first. I'm going to put my plus r second. So notice I put my circles first. And then I'm going to put my rectangles second. And you can do this with any math problem almost. Rearrange, but it's important that you bring the sign with the number. All right, now it's just a matter of combining the circles and combining the rectangles. So what is r plus another r? Well, you get 2 r's. What's positive 8 plus 8? Well, that would be positive 16. Can you combine 2r and 16? No, they don't have the same variable. So you're done or finished. 2r plus 16 is as simplified as that answer is going to get. You can't do anything without, you can't do anything else with that. All right, I said there was another way you could do this. This is what I usually do. So I have my r plus 8 plus r plus 8. I will use shapes sometimes, so r and positive r are like each other, and that's horrible. Let me fix that. I'm not circling signs. Let's try that again. R plus 8 plus r plus 8. All right, r and positive r are like each other. My positive 8 and positive 8 are like each other. So what am I going to do? I'm simply going to do this. R plus r is 2r. So that's why we need to include those signs. Next, I'm going to combine my rectangles. Positive 8 plus 8 is 16. And the sign in between is always going to be positive unless you literally bring down a negative number. Can you add 16 to 2r? No. Don't write anything like 18r because that's not 16r. Don't do anything crazy. This is usually what I do. This takes a little bit more time, but it helps beginners. Next problem, 5x minus 2 plus 3x. I'm going to do both ways again on this one. So let's group them. 5x, let's use a circle. Anything like a 5x? Yes, positive 3x. They both have the same variable, x. Negative 2, it doesn't have a variable, so it's just itself. I'm going to use a rectangle. So first, let's rearrange them. I've got my 5x. Let's put my positive 3x next to it. And let's simply bring down the negative 2 over here on the right. All right, combine the circles. 5x plus 3x, you're going to get 8x. What do I do with the negative 2? Just bring it down. Voila, that's how you get a negative sign, is if you literally bring something down. Can I take away 2 from 8x? No, they don't have the same variable. Can't do anything with it, leave it. So 8x minus 2 is your simplified answer. Okay, let's do that again, but without rearranging them. So 5x minus 2 plus 3x. Again, my 5x and positive 3x are like each other. The negative 2 is just its own thing. So I'm going to read left to right and combine these. 5x plus 3x is 8x. Simply bring down your minus 2. Again, I usually like this because it's faster, but if you're a beginner, rearranging them and clumping them together might be beneficial. 2 more examples. 18 plus 4w minus 13 minus w. We have addition and subtraction, multiple terms. So I'm going to use shapes. So I have a whole number, 18, or just a regular number. What's like 18? Well, negative 13. They're both numbers with no variables. So those are like each other. All right, my positive 4w. let's use rectangles. What is a like term with positive 4w? Negative w. So what am I going to do? I'm going to combine my circles. Read left to right. 18 take away 13. That's why you need to include that sign right there. So 18 take away 13 is 5. Now I'm going to look at my w's. Positive 4w, take away a w, you get 3w. Your answer is always going to be, or sorry, not answer, your sign that you put in between will always be positive unless you bring down a negative number or unless you get to the point like 7th grade and on where you actually add and subtract and deal with negative numbers. We're not to that point in 6th grade, so with 6th grade standards, you're not going to deal with negative numbers. So our answer is 5 plus 3w. Next example, last one. 3y plus 4y plus 5y plus 6y, take away 7y, take away 8y. It's important that you don't try to group these together, or you will mess up. I do have a problem that goes along with these notes, so if you are doing the problems from the Math in Focus book that match these notes, it's important to do it step by step, or you will make a mistake. You've been warned. Okay, so anyways, I have addition and subtraction. There's no parentheses, no exponents, no multiplication or division. It's just addition and subtraction, so you will work from left to right. 3y plus 4y is 4, 5, 6, 7y. Bring down your positive 5y plus 6y minus 7y minus 8y. Next, 7y plus 5y. That's going to be 12y. Bring down your plus 6y minus 7y minus 8y. Next, 12y plus 6 more y, you're going to get 18y. Bring down your minus 7y and minus 8y. Next, 18y, take away 7y, you're going to get 11y. Bring down your minus 8y. Last step, 11y, take away 8y. You're going to get 3y. Can you do anything with 3 times y? No. So that is your answer. I hope this has helped with simplifying algebraic expressions. If it hasn't, I hope you can find what you're looking for elsewhere. Y'all have a great day.